So yesterday we learned 3 properties of special parallelograms, so that's the rhombus, rectangle, and square. Today we are building off of that, and we have 3 theorems to prove that something is a rhombus, rectangle, or square. These are very similar to what we did yesterday, but the if and then statements are flipped. So yesterday we had a theorem that said if we have a rhombus, then the diagonals are perpendicular. Today, our first theorem, so theorem 616, says if the diagonals of a parallelogram are perpendicular, then the parallelogram is a rhombus. So again, the if and then are switched. The second one says that if one diagonal of a parallelogram bisects, remember, bisects means it cuts in half, a pair of opposite angles, then the parallelogram is a rhombus. So again, this is a converse of a theorem we learned yesterday that said if we have a rhombus, then the diagonals bisect a pair of opposite angles. The third theorem for today, theorem 618, says that if the diagonals of a parallelogram are congruent, then the parallelogram is a rectangle. And yesterday we said if we have a rectangle, then the diagonals are congruent. So that's another converse. We are going to use these 3 theorems to prove if a parallelogram is a rectangle, rhombus, or square. So in our examples today, we are going to conclude if the following parallelograms are a rhombus, rectangle, or square. Or it could be none of them. We will see. On this first example, we have a parallelogram, and it looks like we have the diagonals. And it says SO, this diagonal, is congruent to TP, which is this diagonal. And since our diagonals are congruent, theorem 618 says that we have a rectangle. Remember, if our diagonals of a parallelogram are congruent, then we have a rectangle. So this is a rectangle by theorem 618. Next one, it looks like we have another parallelogram with diagonals. And notice this right angle right here, where the diagonals meet, or where they intersect. If the diagonals intersect at a right angle, that means they are perpendicular. And theorem 616 says that if the diagonals of a parallelogram are perpendicular, then we have a rhombus. So this parallelogram is a rhombus. And that's theorem 616. On the next one, it looks like our parallelogram has one diagonal. Remember, the diagonal are the lines that go through the shape from one corner to another. And notice the markings on this one. So we have that the 2 smaller angles in the corner are congruent to each other up here. And these 2 smaller angles down here are also congruent to each other. What that means is that this diagonal bisected both of these opposite angles right here. It cut them in half. Theorem 617 says that if one diagonal, it only has to be one diagonal, bisects a pair of opposite angles in a parallelogram, then we know that parallelogram is a rhombus. So this is a rhombus by theorem 617. Because we know that one of our diagonals is bisecting opposite angles. Next example. We have to be very careful on this one. Notice we have this segment congruent to this segment, and this segment congruent to this segment. It is very easy to get this confused with theorem 618 and say that these diagonals are congruent, but we cannot say that. From this picture, we can tell that the diagonals bisect each other because it looks like they're cut in half, since the two yellow segments are congruent and the two blue segments are congruent. But we cannot tell if the whole diagonals, so the whole diagonals are congruent. We cannot say that. So this does not match any of the three theorems we have learned today, but it does match a theorem we have learned in the past, which says if the diagonals bisect each other, then we have a parallelogram. So this one was tricky. This would be a no. We cannot assume that this is a rhombus or a rectangle or a square. Last example for the day. If you want, you can pause this video and see if you can do it on your own. I will tell you there's two theorems used in this one. Or we can just go ahead and do it together. So first of all, there's two things to pay attention to. First thing is the fact that it says AD is congruent to CB. Those are our diagonals. And since our diagonals are congruent, theorem 618 says that this is a rectangle. But we are not done. If you look, the picture also tells us that these diagonals are meeting at a 90-degree angle, so they are perpendicular. And remember, theorem 616 said that if our diagonals are perpendicular, we have a rhombus. So this shape is both a rectangle and a rhombus, meaning it has 4 right angles and 4 congruent sides. So if you think back to the definitions of rectangle, rhombus, and square, a figure that is both a rectangle and a rhombus, or a figure that has 4 right angles and 4 congruent sides, that is a square. So this is a square by theorems 618 and theorem 16, or 616. These are the examples I have for you today. In class, we did a quizzes for more practice. That quizzes had information from yesterday with the properties of rectangles and rhombuses. And it also has stuff from today. So take the time to go do that quizzes for practice. And I hope you have a wonderful day.